Back, everybody. Here we go. Yes, sir.
So are all of these questions going to be on the test, or is it only a certain number of them?
I don't know. I'd say if it's on this review, then it's fair game. Yeah?
So
Nothing on the test will, how do I say this? Right. Nothing on the test will not be on the review. Yeah. So you will have seen every question from this review.
Okay.
That makes sense?
Is it going to be like the order again? Because these ones are kind of out of order. Or not really.
Oh gosh, I don't know.
Okay.
Yeah. Sorry.
You know what to study then.
Yeah. Well, you know what to study.
Yeah.
Just you don't know when and which part. All right. So the velocity function in meters per second is given for the particle moving along this line. So we want to find. You need me?
What's it?
Did you need me?
I need a marker.
Like a whiteboard marker?
Yes. Yeah.
There you go.
Well, that's my account here.
Oh no, you have to finish your quiz. That's right. I'm glad I started to do it.
I'm just so excited to do this. That's the one where it's like
all right.
intervals.
So here we go. Okay, and we're back. So remember that to find the position, to find the change in position, I want to find the integral, right? I want to find the integral from, well, however much time it takes, right? I got to do the integral from 0 to 6 of v of t, right? V of t dt, honestly. Okay, which is going to give me this. Let's find the antiderivative. We've got t to the third over 3 plus 2t squared over 2 minus 15t from 0 to 6. That's going to give me total distance traveled. I'm sorry, total displacement, and then the total distance. This is going to give me the total distance traveled, right? Because at some points I'm moving in the positive direction, at some point I'm moving in the negative direction. This total is going to tell me the total distance traveled. Total distance traveled. Okay, so we have just to reduce it a little bit, t to the third over 3 plus t squared minus 15t from 0 to 6. So plugging in 6, the nice thing about this is I'm plugging in 0, which means that the second part of this is going to be zeroed out. So t to the third, so 6 to the third divided by 3 plus 6 squared is 36 minus 15 times 6. 18. 18 meters. 18 meters. All right, now, the more difficult part about this is figuring out when it's moving in a positive direction and when it's moving in a negative direction. So looking at the velocity function, I know if a velocity is negative, I'm moving in a negative direction, right? So what I'm going to do here is say t squared plus 2t minus 15 is equal to 0. I'm going to figure out when the velocity is maxing out. When is the velocity equal to 0? Or sorry, when is the velocity equal to 0? Meaning, when am I going to change directions? Okay, so that's going to give me a t minus 5, t plus 5, and a t minus 3, equaling 0. So t equals negative 5 and t equals 3. I know at time negative 5 and at time 3, my velocity is at 0, which means I'm going to have a change in direction. Possible change in direction. All right. So it looks like the only possible one that I'm going to be looking at here is 3. Why? Because negative 5 doesn't make sense, and 3 is within my window that I'm looking at between 0 and 6. So I'm going to find between 0 and 3, and then I'm going to find between 3 and 6. And whichever one comes out negative, I'm just going to make positive. Right? Whatever one comes out negative, I'm just going to make positive. All right, so 0 to 3, that's going to be t to the third over 3 plus t squared minus 15t from 0 to 3. Let's figure out what that is. The nice part about that one is that, again, it's going to zero out on the right side. So it's going to be 3 to the third divided by 3 plus 9, 3 squared, minus 15 times 3. Okay, so there's the one I'm going to make positive, right? That negative 27 is just going to be a positive 27. Why? Because I'm looking at total distance traveled here, right? Even if I'm moving in a negative direction, I just want to see how far I'm moving. All right, so 6 and 3. So I'm going to have to take 6, which was 18, right? If I plugged in 6 here and I got 18, it's 18 minus 3, which is 27. Well, actually, it was negative 27, right? So I'm going to go 18 minus a negative 27. Right? I could run those numbers again just by plugging those in, but that's what I get. So 18 minus a negative 27 gets me a positive 45. So all said and done, total distance traveled, 72 meters. Okay. Which makes sense because this was, the 27 was in negative distance, right? Negative direction, I guess I should say. Negative direction. And the 45 was in the positive direction. 45 came out positive, which makes sense. That confirms my earlier answer of 18 as a displacement, right? I was 18 to the positive, all in total for my displacement, which makes sense because I had moved negative 27 meters and then positive 45 meters. All said and done, I moved a total distance of 72 meters altogether. All right, what other ones do we want to go over? That was 25. What else do we need to see? Any other requests? What do we want to go through? I know we did some of them yesterday. Just a couple of them. Yes, sir.
Number 8.
Number 8. Oh, not the current page. I want a new page. Let's try that again. New page. There we go. The speed of a runner is increased steadily during the first 3 seconds of a race. Her speed at half-second intervals is given in the table. Find the lower and upper estimates for the distance traveled during those seconds, during those 3 seconds. So basically what I have to do here is just, this is before we even knew, but basically find the integral from 0 to 3 using all of these values here. So the lower estimate is this. Remember that I could take this half-second interval and apply it to this speed. Half-second interval, apply it to this speed. This speed, this speed, this speed, this speed. That's the lower estimate, right? So this is 0.5 times each one of those. 0.5 times 0, 0.5 times 6.6, 0.5 times 10, and so on. Or, in other words, 0.5 times 0 plus 6.6 plus 10.2 plus 12.6 plus 12.9 plus 14.8. Is 16.2 getting multiplied by any interval? No, so we do not use it. And for the sake of time, that calculation is 28.55. Total distance traveled, am I given any feet? Okay, that's my lower estimate. My upper estimate is going to be the same thing, but now, okay, I'm going to apply that to 6.6, to 10.2, to 12.6, and so on. So that's going to be 0.5 times, now the 0 gets left off. 6.6 plus 10.2 plus 12.6 plus 12.9 plus 14.8 plus 16.2. Okay, which gets me 36.65. Oop, 5. Stick that 5 in there. My lower estimate is 28.55 feet. My upper estimate is 36.65 feet. I know the actual distance traveled falls somewhere in between those. If I wanted a better estimate, I would have needed to use smaller time intervals to check the velocity. What other questions do we want to see?
9.
9?
Mhm.
Okay. Just take a look at 9. Okay, honestly, we kind of just evaluated a Riemann sum. We hadn't known to call it a Riemann sum when we were doing like the problem 8, but now we know better. We can calculate the Riemann sum. We know that the Riemann sum is basically equal to delta x times the sum of the y values, right? Delta x times the sum of the y values times the sum of the y values. So let's figure out what delta x is. Remember, delta x is b minus a over n. Like the formal formula for it is b minus a over n. You could logically reason it through based on how many rectangles I tell you to take and the interval. Or just run it through the formula here. So it's 6 minus 0 over 6. So delta x is 1. I could have reasoned that through here because I'm knowing that if I want to go from 0 to 6 and I'm cutting it into 6 strips, well, that must mean each width is 1. Okay, so delta x is 1 times, and now I've got to figure out each one of my x values to pick. Okay. Sample midpoints too. That's fun. If I'm going to use the midpoints, then my starting value has to be what? 0.5, right? 0.5. Now, how do I get 0.5? I know that my first delta x is going to be from 0 to 1, right? My first x value, my first strip that I'm going to take is going to be from 0 to 1. How do I know that? Well, I know that my starting value is 0, and I know that my width of my strip is 1. So I know that it goes from 0 to 1. So the midpoint of that is going to be 0.5. So it's going to be f of 0.5 plus f of, now, each strip is 1 unit, so f of 1.5. And then f of 2.5. And then f of 3.5. Looks like I have to make a little bit more room here. Plus f of 4.5 plus f of 5.5. And that's where I end because I don't want to go above 6. And that's my 6 strips too. 1, 2, 3, 4, 5, 6. And it's 6. Okay, now I just evaluate what that is, right? My delta x went out here, and then I have to just evaluate what that is using that function, x squared plus 8. So f of 0.5 would have been 0.5 squared plus 8. 8.25. Okay, so 1.5 squared plus 8. 2.5 squared plus 8. 3.5 squared plus 8. I don't want to get too far ahead of myself. Okay, 10.25. Just going to put it here. 10.25. 14.25. 20.25. Okay. Ooh, don't do that. And then we keep going. So that was 3.5. So 4.5 squared plus 8. And then we have 5.5 squared plus 8. So an additional 28.25 and 38.25. Okay. Didn't expect that. 28. Oh, what you doing? Getting back there. 28.25 and 38.25. Just running those values through the equation. And 119.5 looks like.
So if it asks for midpoints and it's like always going to start at 0, then it's going to be 0.5.
Yeah. Well, I wouldn't say 0.5. Like, think about it this way. If I went from 0 to 3, and I said n was 6 still. Okay, so that means delta x is going to be 3 minus 0 over 6, so 1/2, right?
Yeah.
So each strip's width is 1/2. So now my first strip is not 0 to 1, it's 0 to 1/2. So what would be the midpoint of that? 0.25.
So if you're changing x is 1, then it's half.
Right.
Okay, got it.
If your delta x is anything else, then you just have to calculate, okay, what would that be? Take half of it. Yeah. So and like on the flip side of that, if I had said, okay, I'm going from 0 to 4, and I'm only, well, let's make that a little bit different. If I'm going from 0 to 10, and I wanted just 5 strips. Okay, so now that means my delta x is going to be 10 minus 0 over 5. So delta x is 2, right? So that means each strip is 2. So now my midpoint would have been at 1. Does that make sense?
Yes.
Okay. So it all depends on the width of each strip and how many strips you're taking. And that will tell you where your midpoint is. Questions on that one? Okay, what else do we want to go through?
17.
17, sure.
I got a negative, but it said like positive for the key, and I can't
Ooh.
figure out what went wrong.
Let's see what happened. Send to a new page. Okay, we got cosine x plus 2 sine x dx. All right, so let's evaluate the integral using the that FTC2, the antiderivative rule. All right, so what is the antiderivative of cosine? Sine, right? Sine x plus, actually, I was just going to write plus, and I think it's going to be minus, isn't it? Yeah, because the antiderivative of sine is negative cosine. So that would be minus, get rid of that little mark there, minus 2 cosine x from 0 to 6. And then we just plug in. What did you have as an answer?
I had negative 0.2. Really?
I think my keys are just the way I'm writing it though, but let me just keep going though. Sine 6 minus 2 cosine 6. All of that minus sine 0 minus 2 cosine 0. Okay, let's evaluate that. Sine 6 minus, in parentheses, minus 2 cosine 6. And I've got negative 2.2 minus, and then we've got sine 0 minus 2 cosine 0. Yeah, that's a negative 2. So that actually should have been a negative 2.2 plus 2. So yeah, negative 0.2. Should have been a negative. I do have a positive on my key.
That's great.
Gold star for the day.
I remember talking about this question, and I was asking like how to round.
Yeah.
Yeah.
Round it. I won't take off for rounding issues. I usually go to the nearest tenth or nearest hundredth, but other than that, I don't know. I wouldn't be too picky. Yeah. What other questions do we want to take a look at?
19 and 20.
19 and 20?
They're both kind of similar.
Okay. Oh, yeah. I like these ones. Let's do 19 and 20 then real quick. All right. Sketch the region enclosed by the given curves and calculate its area. So first thing's got to sketch. Here's 19. We know it's going to go from y equals 0 and x equals 6, right? So that basically means that I'm going from my horizontal line, y equals 0, and my vertical line, x equals 6. So out here at 6, I'm going to put a boundary line. And I'm just going to draw in my square root of x. and I want to find the area enclosed here. Now, it didn't tell me to find an integral, but that's how I find the area, right? It didn't say evaluate the integral between No, but this diagram is equivalent to this integral from 0 to 6 of the square root of x dx, right? Okay, let's find the antiderivative. So the square root of x, remember the square root of x is equal to x to the 1/2 power. So that means I'm going to say x to the, so since that's 0.5, I'm going to say 1.5 over 1.5 from 0 to 6. Let's evaluate that. 6 to the 1.5 divided by 1.5 is 9.8. Okay. Oh, minus 0. Yeah. 9.8. Right? Yeah, I said 9.79, but whatever. That's not even rounded, right? 9.79. 9.8 is better. So that is 19. And then the same thing for 20. 20 requires just a little bit more work because it's basically a reflected parabola, right? With a y-intercept of 36. And then it goes down here and here. And I want it to stay above y equals 0, right? The region bounded by y equals 0 and this parabola. So this is the area that I want in here. Well, that means I want the area under the curve of x squared plus 30, negative x squared plus 36 dx. And then I have to figure out what x values I want. Well, this is very similar to the one that we had on our quiz here. I just need to figure out what these values are. Well, those are just the zeros of the parabola. Negative x squared plus 36 equals 0. So 36 is equal to x squared. So plus or minus 6 is equal. That's an x. It's a poorly written x there. X is equal to plus or minus 6. So that means from negative 6 to positive 6. That's what we want to find. Alrighty, let's take a look here. That means I'm going to bump that up one. Negative x to the third over 3 plus 36x from negative 6 to 6. Now be careful. As I'm looking at the diagram, am I going to get an area of 0? No. And that's a very common answer to say, is 0. Because the numbers look like they're going to cancel out. When in reality, isn't this area the same as this area? So it's not going to cancel out. It's going to double, right? That yellow area is going to be the same as the purple area there. So be careful with that. A lot of people always tend to say 0. It's not going to zero out. So this is going to be negative 6 to the third over 3 plus 36 times 6 minus negative 6 to the third over 3 plus 36 times negative 6. All right. So we have negative 6 to the third divided by 3 plus 36 times 6, which gets me 144. So I'm guessing that the area is going to be 288. But let's check and make sure. And then on the top, so we have negative 6 to the third. Oh, yikes. Negative 6 to the third, much better, divided by 3 plus 36 times negative 6. Negative 144, which makes sense. See, this is where a lot of people get thrown off. They say, oh, that's going to cancel. It's going to be 0. No. It's going to double, not be 0, because that's a big plus. So 288 to the positive. What else do we want to go over?
We did 23, right?
I don't know.
Yeah.
Did we?
Oh,
Yeah.
we did that yesterday.
Did we do that yesterday? Yeah, we did that.
24.
You know 24? Now 24, you may be tempted to try to find the integral using tangent. I would say resist temptation. Try to manipulate it a little bit before you find the integral. Here's what I mean by that. What is tangent? No, what is just tangent equal to? Not the integral of tangent. Sine over cosine. Right? Cosine theta. So now I have cosine theta times sine over cosine. And what's going to happen to those cosines? They're going to cancel. So this actually ends up being the integral of sine theta d theta, which is, what is the integral of sine? Cosine. Just regular cosine, right? Yeah. Oh, negative cosine. Excuse me. Negative cosine. Negative cosine theta. And then if it's an indefinite integral, plus c. Remember, indefinite integral is equivalent to saying general antiderivative, right? And that's kind of where, like, this whole, I don't want to say whole chapter because we still have part of chapter 5 left, but this whole set of sections that we have is kind of coming full circle because we started in section 4.9 just by plainly finding antiderivatives. And now we're finishing with calling those antiderivatives, those general antiderivatives, general indefinite integrals. Yeah. 14? Yeah. Oh, yeah, that one. Okay. You do. All right, use FTC1 to find the derivative of the function. Remember, FTC1 basically just states that if you have an integral, the derivative will undo it, and likewise, vice versa. If I have the derivative, an integral will undo it. If I have the integral, a derivative will undo it. They are inverse operations of one another. So if I wanted to find the derivative of this, basically what I'm going to be doing here is taking this piece, and I'm going to input it right into there, and then multiply back on using the chain rule. Because if I find the derivative of this, if I take like d over dx of this, that's going to cancel this and this and this. Okay, which is basically going to say 8 over 3x squared minus 2 plus 6. And then I have to find the derivative. If I find the derivative of this, I got to keep going inside there, peel back the layer, and now find the derivative of 3x squared minus 2, which is 6x.
Chain rule, you plug that thing with that thing. And then
Yeah.
times it by the chain.
Yeah.
Okay, great. So you just plug it like that's x.
Yeah.
Okay.
So this goes in place of x.
Times it by the chain.
And then I multiply by the derivative of this. Okay, so 54x. Mrs. Mind was blown for a second there. She's like, whoa.
Still keep going for the chain rule, guys. It's okay.
Yeah, really. All right, and now we can. Oh, is there anything to simplify? I don't think I can.
Tripping, or should that be
48.
48.
Whoa, 54. Yikes. Whoa, man.
No, I'm not tripping.
I don't know. Jeez. Ooh, 6 times 8 is 48, not 54. That's 6 times 9. Ooh. Yeah, really. All right, 48x over 3x to the 4th plus, or 3x squared plus 4. Again, if you could reduce that down at all, you would have to, but this one does not reduce. Okay. Yeah, that negative 4 just kind of goes away. Can't do anything with that. Number 11. All right, evaluate the integral by interpreting it in terms of area. Use a graph within your solution. All right, so this is the one where I'm going to ask you to graph out that function and then use that to find the area of find that to use that to find the area of using the integral. Whatever, you know what I mean. Let me get a graph real quick. I think this one will work. 6 minus 2 is 4. Yeah, I think so. Okay, first thing I want to do is graph 2x minus 2 along the interval -2 to +3. All right, so that means I've got a y-intercept of -2 and a slope of 2. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And there is my interval going up to 3. I need to go backward to 2, though. Down to left 1, down to left 1. So just from the interval of -2 to 3, there's my line. Now I want to find the integral by using the areas. What does that mean? That means I'm going to find this area. And is that area going to be positive or negative? Negative. Then I'm going to find this area. And that area is going to be positive. Just generally speaking, it looks like my area is going to come out negative, right? So let's find the red area. The red area is 1/2 my base. Looks like it's 1, 2, 3 units. Times my height. Looks like it's 1, 2, 3, 4, 5, 6 units. So that's a total of 9. So -9 area. And then using the green, 1/2 base of 2 and height 1, 2, 3, 4. So that's a 4. Positive 4, right? So all said and done, that's equivalent to -5. Just watch out. Remember, the one I think on the quiz came out so that it didn't hit the axis nicely. So just be aware of that. It might not come out at a nice value. You're going to have to kind of play around with that and see where it's going to actually hit. Remember, you can always find the x-intercept by setting that equal to 0. You know, like if I had something like 3x plus 5, if I wanted to graph 3x plus 5 and I wanted to see where it was hitting the x-axis, remember, just set that equal to 0. 3x equals -5. So x in that case would have been -5/3. I don't think I'm going to give you anything that weird, but just know that you can always do that if you needed to. Yeah.
For the test, would it be the same as a quiz where, like, on this, 10 and 11 would be equal to the same thing?
Yeah. I'm going to ask you to do that same type of thing where it's going to be the same value. You should know this, it's not be the same. About 10 minutes left. Any other questions? Just think after this, there's only 2 more sections to learn. 5.5 and 6.1. Only
2 more homework.
2 more homework assignments.
That's crazy.
That is one.
And if you choose never to take a math class again, those are like the last 2 math homework assignments that you want.
That's pretty crazy. To think
That's
about.
crazy. Imagine like that. I think I'm about to do math.
Imagine that. All right. I thought I was done with math classes, and then I took more in college, and then I took more,
And you took more
and then I took more out of college, and then I took more after I became a teacher, and then I took more. So.